Hello everyone, we want to talk about electric field and I'll be discussing some things about the electric field. Number one, talk about definition of electric field. I'll talk about definition of what? Of electric field. Under this definition, I'll be looking at how it tends to affect how it affects. It creates on a charge. Looking at the effect it creates on a charge. Then I'll also be looking at how do we detect how do we detect electric field? I'll be doing that quickly. Then I'll also be talking about the electric field of a reference charge or source charge placed at a distance from a point in a field. So let's start. Let me start with the first one. This is like introduction of electric field and I want you to listen. Very easy. Electric field is a region of space around a charge. Around a charge placed at a point where another charge in the region experience a force. So that means that if I have a charge here, what I'm saying is if I have a reference charge here at this point, and let's say I have it is creating an electric field. Like for example, this is let's say a positive charge. Now this positive charge will create an electric field around it. That will be in the case that when you now have another charge, maybe a positive test charge now, it will exert a force on this, or let's say another charge is placed here. It will exert a force on this one. If it is positive charge, it will repel if create a repulsion force. If it is negative charge, it will create an attraction force. Now that means that a static charge always creates an electric field around itself. So that means that electric field is a region of space around a charge placed at a point where another charge in the region experience a force. Now that is it. Now what again can we know about electric field? Now when a charge is placed, a static charge is placed in a field, it creates an electric field, and this electric field exert a force on that charge that created or produced that electric field. It creates when the electric charge is placed in a field, a static charge. What you notice is that static charge will produce or create an electric field and exert a force on the charge that create that electric field. So that is what it does. Now, how do we detect an electric field? How do we detect it? How do we know the presence of an electric field? Because by a reference charge. What you are going to do is to place a unit test charge, small enough not to alter the location and distribution of these reference charges that are in the field. Once you can do that, go to that test charge that you are placed in the field, calculate the electric field on that test charge. Now don't forget that if you place a positive test reference charge, now for example here, and let's say we place a test charge far from it, now for example let's say distance G, or let me use R. from this what point. Now I want to calculate electric field at this point. What am I going to do? What we are saying is that place a positive test charge with a what? A non-polarity. It must be a non-polarity. Please don't forget, because you must know the polarity. And most of the times what we use, the small test charge that we use of non-polarity is +1. So that now you now want to calculate the electric field at this point. What you're going to do is to look at the reference charge. It is positive, abi? Okay. Positive and positive, what do they do? They will repel. So it will what? Create what? Its own electric field here. E will be created that way. That is what we call electric field of a what? Of a reference charge, or of a charge from at a distance r from a point. Now, what is another basic definition of electric field? Electric field, what? Can give you another definition. Electric field is defined as what? The magnetic force, sorry for this marker, as the what? Electric force, rather, experience electrostatic force. You can put electrostatic force, experience what? Per unit what? What? Test what? Charge. Per unit test charge is what? Electric field what is defined as the what? The electric force experienced per unit what? Test charge. Meaning that we can write it like this: F is equal to what? Or E is equal to what? The force experienced, electrostatic force experienced per unit what? Test charge. That is the formula. Now, if we want to now what? Break it down, we can say the force that is being experienced, because I told you that what? That electric field around this charge what? That the charge producing the what? The electric field will exert a force. And when you have a charge that produces or what? Create an electric field, it will exert a force on the charge. It will exert a force on the charge that created the what? Electric field. So what is the force it's going to exert? It's going to be between these two charges now, separated by a distance, which is what? K, Q what? Reference charge, and what? Q naught divided by what? R square. That is what? The formula. Now that is the force. Now this force that we have now, which is this, if you now divide it here, you put in the formula that we have up there, I would have E is equal to what? Simply what? K, reference charge, unit test charge or test charge, divided by what? R square times 1 over Q naught. Don't forget, if you put it here, you say, don't forget, this one is same thing as F times 1 over absolute of what? Test charge. So now that's what I have done. So this one will cancel this now, class. So what do we have now? We are going to have as what? E, which is what? Is equal to what? Equal to KQ over R square. If I'm putting this there, I'll put what? A unit vector here to show that it's a vector, has magnitude and what? Direction. But this is a unit vector. I will talk about it later. Now let's say E is equal to what? Let me take the magnitude, electric field intensity. It's equal to 1 over 4 pi epsilon absolute of reference charge over R square. This is in a medium. What about in air? E will become 1 over 4 pi epsilon naught, then absolute of what? Reference charge R square in air. This one is in air. So the formulas are very clear. If it's in air, to calculate the electric field at a distance d from a point, you understand now? Which formula do you use in air? This is. What about if you want to calculate what? The distance of a charge from what? A distance of reference charge Q at the distance R from a point in a medium, you use this one. Now this one indicates magnitude and direction because this is a unit vector. How do we now know? Because we know that we know that what electric field is, what it has magnitude and direction. I've talked about effect. I've talked about how to detect the electric field. So I've talked about this is where we are now, the last part. Now, but we know that electric field is what? That which has magnitude and what? And direction. It has magnitude and what? And direction. So if electric field has magnitude, electric field, so let me clear this other side. So electric field what? Field has what? Magnitude and what? And direction. How do we calculate the direction and the magnitude? First of all, if I what? The direction of an electric field depends on the polarity. So the polarity is what decides the direction. Now, if you have a positive what? Reference charge or source charge, and you place a what? A test charge closer to it, what will happen is that that positive test charge will move away from the what? From the positive source charge. This is source charge. Let's say this is what? Test charge. Now, if I have a negative charge now placed at a distance, let's say D, at a distance of D also from a what? A test charge. What we notice is that it will move towards the what? The positive. So that is to say, if I have positive, they will repel like this. This is what will happen. That means outward from the what? Away from the positive charge. This is away, and this is what? Towards the positive charge, negative charge rather. So it will be away, like what we have explained. Then if you have a what? A negative and a negative, what happens? It will move up towards. Look at the arrow. It will move towards the what? Inward, towards the negative charge. And the two of them are showing like what? Charges repulsion of like charges. What about what? Unlike charges now? This is positive and negative. They will what? Attract. They will attract each other. And it will move away from the positive and towards the what? Negative. This is attraction. And this is what? Repulsion. So in this case now, what we are saying now is that the direction of the what? Of the electric field is what? Away from the positive charge and to move towards the negative charge. It basically instructs us that what? The direction of electric field what? Depends on the polarity. That's what he's talking about. Polarity of the source charge. Polarity of the source charge. That's what he's saying. Another thing, to calculate magnitude. To calculate magnitude, you use this one, depending on the condition, or you use what? This. So to calculate magnitude, if it's in air, use the second one. If it's in a medium, use the first one. Basically, you can see right it as what? K Q over what? Epsilon naught R square. If it's in medium, so that is E in what? In medium. Now you can write it like that. It's the same thing. If you go and check my class in chapter 1, you can write this one as what? Epsilon is equal as epsilon R times epsilon naught. So if you put it there, here, you are going to discover that our K, which is K naught, will now be equal to what? 9 times S by 9, which is K naught will now be 1 over, K naught is 1 over 4 pi epsilon naught. That is K naught for you. So if you isolate this one from this formula, let's say this is what? Epsilon naught, epsilon R times R square. If you isolate what? This, you are going to have what? K naught. And what we are going to have left is what? Epsilon R. But if it's in a medium, in air, epsilon R is equal to 1 in what? In air. So it will take it as 1. So the formula will change to this formula from here to this. So those are the things you need to know. And this is what we call electric field intensity, which is electric field strength. Now, the strength of the electric field is this one. This one, it measured only the magnitude. But this one now, it shows magnitude and direction because of the unit vector here. The unit vector arrow word unit vector. So that is that. Now, which other thing do we need to know concerning this? We are going to talk about that basically in the next chapter, part 2 of this electric field. But at least basically we have introduced and lay a good foundation that you must have at the back of your mind. Don't always forget that what electric field is, what is can be created by what a static charge, and this static charge there's a region of space around this charge. That when another charge is placed in that, it experiences that force. And when you want to detect electric field, whenever a source charge is placed in a field, you introduce a test charge that is small enough not to alter the location and the distribution of this source or reference charge that is placed in this field, so that when you are now calculating the electric field, you focus on the test charge. You indicate the direction of the word or movement of the arrow. If it's going, this is the electric field of this charge now, and this is the electric field of this charge. So that is what you must know. Another thing again you must know is that what the relationship between electric field and what and distance apart here. You must not forget that electric field has a relationship between what E and R. E is inversely proportional to R. You understand that? E is inversely to R square. So if E is inversely to R square, we can say E is equal to constant over what? Let's say constant. To use a constant, you can use any alphabet over R square. Now let us what? That means if you remove the proportionality, you can use any constant. You can use P. It can be E, that is E equal to P over R square. Now what is our P? P is constant there. Now another thing again you must do here, let's make the P the subject of our P equal to what? E R square constant. So if you are given two electric field and one radius, have to find the other radius, you can say E1 R1 square equal to what? E2 R2 square. Now don't forget that the smaller the what, the closer the source charge to the test charge, the higher the what electric field. The closer the what this charge to this test charge or to the point, the closer the distance, the higher the what electric field. The farther the distance of the source charge, the lesser the electric field. So they are inversely proportional. Take note of that. So we can use this formula to solve problem that has to do with giving two electric field and giving one distance to find the other, or giving one distance, two distance and one electric field to find the electric field strength of the second one. When sometimes they will say what the charge is moved closer or is moved farther away. Initially it was 2 meter distance closer to the test charge, maybe 2 meter. Later they move it to 4 meter. Automatically mean the electric field will drop, because the farther the distance, the lesser the electric field. Then the closer the distance, the higher the electric field. I believe I've been able to explain and introduce this topic to you. In our next class, we are going to be looking more and more. And somebody will ask me, what is the unit of electric field? That is it. Unit of electric field is what? Newton. No, this is Newton, and this is what? Coulomb. This Newton Coulomb. So we can call it what? The unit of electric field. The unit is what? Newton per Coulomb, in case you are asked. But I want to ask you a question, which you have to type at the comment section and send to me. Just type it at the comment section and comment and like the video if you enjoyed it. What are the unit of what? What other unit did you know concerning what electric field? Apart from Newton per Coulomb, which other unit can you type that is correct about the unit of what? Of electric field. Don't forget that unit of electric force is Newton. This is a vector form, that kind of word. So what I want you to do for me is what? Write the unit, other unit apart from what is already written here, Newton per Coulomb, and type it at the comment section. Thank you very much for watching. God bless you.